A very good morning. So, the previous class we have been learnt what are sets, relations and functions, right? So, in the second year, the first lesson is your relations and function. This chapter will hold carries of 9 marks in board wise. So total how many marks? 9 marks. So here what happens? Here this will be in this chapter, it will be including of 3 marks, 5 marks question along with MCQs and fill in the blanks. So let us learn what is the relation and functions. When it comes to relations and functions, as you know previously in the previous chapter, that is the previous year, you have been learned only relations and what is a function, right? Here you will be learning in detail what is a relation, what are the types of relations and what is a function and what are the types of functions. So in relation what happens? So we have been learning in relation the most important word called Cartesian product. We have been learnt about the relations like general relations like father and mother, sister and a brother, son and mother, daughter and a father. So like this we have been learning about the relation. Then how it is related in mathematics? Yes, obviously in maths also we have a relation. So for example, P is less than Q or P is greater than Q. Or you can say as line M is perpendicular to line N, or you can say line M is parallel to line N. So like this what happens, each and everything we can find the relations. So as you know the definitions of a relation, in a simple wise I will tell that the relation is a subset of the Cartesian product of a set. So we usually say it has the Cartesian product as any kind of set A cross B. A cross B means set of those elements in A has been Cartesian product with the set of elements of B. For example, let us take A is having the elements of 1, 2 and 3 and B is having the elements of 4, 5. So what is the Cartesian product of A cross B? We can write it as A cross B is equal to 1, 4, again 2, 4, 2, 4 and 2, 5, 3, 4, again 1, 5, 3, 5. So like this we have been finding the Cartesian product. Now how these Cartesian product are related to the relations? Very simple. As you know, when the Cartesian product has been defined, there is a one thing you have to remember. For every Cartesian product there is a relation defined between the two sets. Either it may be a greater than, either it may be a less than, either it may be a similar, or it may be a equal, or it may be a parallel or a perpendicular. It may be any kind of relation. If the relation is satisfying with the given Cartesian product, then we can call it as a subset of a Cartesian product. That is, we call it as a relation. When it comes to relation, there are different kinds of relation. For example, empty relation, universal relation, trivial relation, symmetric relation, reflexive relations and transitive relation, and the last one is equivalence relation. Here in this second year syllabus you will be learning the complete of relations and functions. So let us learn one by one. So the first one is your empty relation. The first one is empty relation. The word it says as empty. Empty relation means for any relation of R, there is no element that is a subset of A. For example, let us take A is equal to A and B is equal to set of all those children which are present in a PUC more than 100 years of age. Is it possible? No. No one are there more than 100 years of age in your college, right? So that is an example for empty relation. So the next relation is universal relation. Universal relation is very simple. As you know the word universal relation, it defines, it intake all kinds of relations. For example, let us go to the previous example problem. So previous example. So let a set A and set B, the set of A be the set of elements of students which are less than 100 years, and set of B the students of Acharya less than 100 years. So the universal means what? It all intakes. Yes, we are all less than 100 years, right? So here what happens? This is an universal relation. Why it is an universal relation? Because the universal, it takes all kinds of relations by itself. So that's why it is a universal relation. Obviously, the age of less than 100 years means everyone are included from 0 to 99, 0 to 100. So what happens? Everyone are included here. So that's why it is a universal relation. Sometimes what happens? There is a peculiar relation, we call it as trivial relation. In this trivial relation, what happens? Those relations which satisfy both the empty relation and the universal relation is called as trivial relation. What does it called? Trivial relation. Means what? For example, in Acharya, so we have every kinds of department. So in those department, every human being or every lecturer includes here. So here what happens in trivial, we cannot say that the plants are doing the lecturing part. We cannot say that the benches are doing the lecturing part. So what happens? It is an empty relation. That is not possible. So when it comes to universal relation, those kinds of relation which are able to do with a given certain conditions of the relation exposed. So that is called as trivial relation. So that's why we call both empty relation and universal relation as trivial relation. Now the next relation is reflexive relation. So the reflexive relation is very simple. When I take a mirror in my hand, what happens? My reflection will be there. Is it true? Obviously. Here also, when you are defining any kind of set, it should be mapped with its own reflection, that is its own value. So then we call it as a reflexive relation. That is the condition we write it as A comma A, which belongs to the relation R for every A belongs to A. For every A belongs to A. For example, let us take A is a set of 1, 2 and 3. A is a set of 1, 2 and 3. Let us define some R here. So R is nothing but some relation which has been given as 1, 1, 2, 2 and 3, 3. Again 2, 1, 2, 3, 1, 2, 1, 3, and anything else is replied here, 3, 6, 7 and 3, 1. 3, 1. So these are the relation I have taken. So how does this occur? Means I have just taken the Cartesian product of A cross A. That is the relation form. Then how can I check this reflexive part? Very simple. In reflexive part, what does it say? It has its own reflection. Means if I take this has one element, the next element, its reflection should be 1 itself. So can you tell which are those elements? Yes, there are 3 elements here. So the first element is 1, 1 and second element is 2, 2 and the third element is 3, 3. So which belongs to R. And what does it say? For every A belongs to A. Means what? You have to check it for every element of the given set A. Then only we call it as a reflexive relation. Next, the second topic is, the second thing is symmetric relation. Symmetric relation. Here what happens in symmetric relation? It always defines as, if A comma B belongs to R, this implies we can say it has B comma A also belongs to R. This is the condition. So what does it say means, if I take the element of A and if I take the elements of B and given the relation has R is equal to A comma B such that A plus B is equal to N. What have been taken? So the relation I have been defined, if any kind of 2 different elements I have taken here, it should give a same replicant of the event. Let us take in the set A, what does it set A says? Set A is equal to 1, 2 and 3. 1, 2 and 3. Let us check whether it is satisfying the condition. So here I will take as set of even numbers. Okay, so let us check which are the even numbers will occur after defining the given set. So R is equal to, if I take here 1, so A is equal to 1, B is equal to 1. So what is the element I will get? 1 plus 1 is 2. So obviously 1 comma 1 appears. That is 2 is an even number. Next, again check it for 1 plus 2. Is it possible? No, 1 comma 2 is not possible. Next, check it for 1 comma 3. Obviously it is possible. 1 comma 3 is there means obviously 3 comma 1 also possible. Next, check it for 2 comma 1. No, it is not possible. Is it possible for 2 itself? Let us check. Yes, 2 comma 2 appears because 2 plus 2 will give the value 4. So hence it is even. Let us check whether the given 2 elements is an symmetric or not. So as you know, 1 comma 1 is there, it is a reflexive and here also is a reflexive, but 3 comma 3 is not there, hence it is not a reflexive. Let us check it for a symmetric condition. So what does the symmetric condition says? A comma B belongs to R means B comma A also belongs to R. Obviously 1 comma 3 is present and as well as 3 comma 1 is also present. Hence it is a symmetric condition. Means what? For every element of first element of A, if it is including the same element and the second element of the given set of ordered pairs, the second element should be present as a first element. So this defines as a symmetric relation. Next, the relation is transitive relation. Transitive relation. Here in transitive relation what happens? We are taking 3 different elements. So the 3 different elements is nothing but A comma B belongs to R. Then B comma C should be belonging to R. Then only we can call it as A comma C belongs to R. So let us check the condition with a problem. So the condition is A is equal to, so 1, 2 and 3, and let us check for R. So what are the elements? 2 power 3 means 8 elements should occur. Let us see. So 1 comma 1 is present, 2 comma 2 is present and 3 comma 3 is present. Next 1 comma 2 is present, again 1 comma 3 is present. Next 2 comma 1 is present, and obviously 2 comma 1, 1 comma 2 is there. Again 3 comma 1 is present, again 3 comma 2 is present. So how many elements are there? 3, 6 and 8 elements are there. So 2 power 3, which gives the value 8 elements. In these 8 elements you need to check it for which relation? Transitive relation. Let us take A is equal to 1 and B is equal to 2 and C equals to 3. So what is the condition they have been told? The first condition is A comma B is belonging to R. You have to check. Let us check. What is the element of A here? 1. And what is the element of B here? 2. Is 1 comma 2 is belonging to R. Check the elements. 1 comma 2 is there? Yes, it is present. 1 comma 2 is there. So which it is belonging? To the element of R. So therefore 1 comma 2 satisfy. Next thing is B comma C you need to check. Let us see B comma C whether it is there. B comma C should belong to R. What is the value of B here? 2. And what is the value of C here? 3. 2 comma 3 is there. Check it out. 2 comma 3. 2 comma 3 is there? No. 2, 3, 6, 8. Sorry. 2 comma 3. 2 comma 3 is there. Yes, obviously. So it belongs to the value of R. Okay, na? So here it is present. Next, in the same way, A comma C, which belongs to R, check it out. What is the value of A here? 1. And what is the value of C here? 3, which is belong to the value of R. Is there any presence of 1 comma 3? Obviously it is present, that is 1 comma 3. Hence we can say it has all the conditions satisfied in transitive, hence it is a transitive condition. So this completes your whole relation kinds and types.